Yeah, good afternoon, good morning to this webinar about the browser client options for the SmartComponent Library framework. On behalf of the whole team at Consulting Werk, I'd like to welcome you to this webinar. It's the second webinar in this series of webinars. 2 months ago, we did the first webinar about a general overview of the SmartComponent Library, including a brief introduction to different client options. In the second one, we're focusing, we're starting with a short overview of the whole framework, but focusing then on options to build browser-based clients for SmartComponent Library. And in 2 months from now, in April, we'll be doing the next webinar, which will introduce then our options for building native script-based mobile applications accessing the SmartComponent Library backend. Yeah, let me briefly introduce Consulting Werk. So we're an independent consulting organization, but we're focusing on the open edge technology and other technologies that well, can be used in a in combination with open edge, very often as different front-end options. Our main office is based in Cologne, in Germany, but our team is spread in 2 or actually in 3 additional countries. But we have subsidiaries in the UK and Romania, and 2 of our colleagues are actually working out of the Netherlands. We're working with customers all over Europe, with customers in North America, Australia, and South Africa. And we're a vendor of developer tools like the SmartComponent Library, and we're a provider of consulting services. And well, there are a couple of areas that we have a lot of expertise in. GUI for .NET as a front-end option, using Angular as another front-end option, object-oriented programming in open edge, software architecture in general, application integration, and so on, are topics that we deal with a lot. And in fact, a large number of the projects that we're doing with our customers are modernizing existing open edge applications in various different ways. Briefly introduce myself, Mike Fechner. I founded Consulting Werk 14 years ago, and I'm supporting customers as an architect. I'm also the product manager of the SmartComponent Library and the WinKit. I'm using Progress since 28 years now. Started with version 5, and well, I think I need to update that bullet point very soon. Dealing with OpenEdge 12 since a while already, I'm spending a lot of my time with object-oriented designs, typically for open edge application, software architecture, desktop user interface. In the past years, more and more web technologies. However, I'm not a full hard web expert, so I brought to this webinar today my co-worker Radu Nicoara. He's working for us as a consultant, as a developer. He tries to hide it, but he has 5 years of open edge experience. But he has much more fun when he can work with modern web technologies like Angular, TypeScript, NativeScript, and Node.js. He is actually in very large parts the developer of our SmartComponent Library, Angular, and NativeScript clients, and he's also supporting our customers and providing consulting and training services to our customers for the web and mobile options of our product. We're still celebrating the 10th birthday of the SmartComponent Library during this winter. We actually started prototyping at the end of 2008, not 2018, 2008. And the actual development, the formal development on the Smart Component Library product started on January the 17th, 2009. That's where we started the development branch. It was with planning and trying around before, but that makes it a 10-year-old product now, which can be quite a long time for technology, but it hasn't aged. We're still adding new features on an almost weekly basis. So with a long history, and I believe I can say a pretty good history also in being pretty stable and offering our customers an environment that helps them focusing on application development and let us work on more technological or architectural challenges. And we managed to be quite good at moving also business logic that some of our customers have developed 8, 9, 10 years ago with first version of the framework into today's versions, and then enabling them to use the most recent developed features. So in this webinar, I want to give you a very brief overview of the whole product. A little bit on the back end. There's some components in the back end which are also very relevant for our methodology for building front-end applications, so we can't focus just on the back end, just on the front end. And then we'll talk about different options for building web clients, and on a very high level, we can differentiate them in either accessing RESTful endpoints as an open de facto standard for accessing backend from web applications, or a very Progress OpenEdge and Kendo UI specific approach, which is using the JSDO as a JavaScript or a TypeScript library. We support both equally well. And based on the JSDO-based endpoints, we have our own Angular-based client components for building web applications that we'll introduce you. And in the end, Radu will be showing some of the flexibility that we allow our developers to use in case that maybe you need to build your own components, or you want to change the styling so that you achieve exactly the styling that you want to have, that you want to serve to your customers, or add components that we haven't thought about during our product development, or that are very specific to the needs of your component, and how easy it is to integrate them with our built-in functionality. So on the high level, what is the Smart Component Library? The developer framework, and we believe it's one that helps developers to be both productive and flexible. We provide tools that aim developers to reduce or avoid boring, unproductive, repeating tasks. We generally integrate with many of the different tools that Progress Software provides, starting from OpenEdge and Telerik for web-based UI technology, the Kendo UI builder. We have integrations with OpenEdge BPM, Corticon, different data direct products, and so on and so on. So that's a list that we always extend as soon as Progress provides new tools that have a relevant integration for, or that provide relevant additional value to an OpenEdge application. So OpenEdge is typically in the core of everything we do. And the Smart Component Library provides an application framework. It provides APIs that solve a lot of routine tasks during the development. It provides foundation classes for building the business logic or the front-end logic objects that developers would be building. We also have application framework features like authorization for many functions that you might have in an application, starting from menu level authorization, field level authorization, access to deletion of certain tables. The authorization can be extended with what your own needs. So maybe you could use our authorization module to authorize, I don't know, different users from running reports in different regions, where a region would be an application provided dimension for the security system and so on, as a batch scheduler. So there's a lot of built-in functionality that we provide, and all this functionality is designed so that it can integrate with existing applications and frameworks. As a matter of fact, most of the customers using the SmartComponent Library haven't started building new applications. Typically, the SmartComponent Library had to be integrated with an existing application, and then there's always a requirement given to integrate functionality that we have with functionality that's already there, or step-by-step replace functionality that was already there with functionality that we provide, or maybe even keep something like the menu security system of the existing application forever, because it might have very, very specific features that you need, and well, then why replace it if it's still usable? The framework is developed in a pretty modular fashion. The individual parts of the frameworks can be used as needed, and typically, yeah, picking them and leaving out other functionality doesn't impact the behavior of those components that you need. There may always be some limitations to that, but generally I believe we have achieved there a pretty flexible design. The majority of the tools that we provide to our customers are written using the SmartComponent Library itself and using our own tools. Most of the tools are written in the ABL. Of course, when we talk about the web front-end options, that cannot be that cannot be ABL code, but a lot of the tooling that developers can use on the backend or for building the backend, all that is ABL tooling. We ship the full source code to our customers, and customers are explicitly allowed to make changes to the source code. Typically, that's something that's not happening very often because we do very frequent releases. We provide somewhere between 40 and 45 releases a year, so that's almost weekly. And in order to be able to stay current, typically our customers have a demand to stay on a standard code base. And if a customer wants to change a little bit somewhere, then typically we discuss with the customer whether or not we can provide a customization hook that would allow to change the behavior in that specific location without having to impact our code. We provide technical support and maintenance offering. We are always eager to announce support for new OpenEdge releases as soon as possible, in typically no longer than a month. Most of the time it only takes a day or two for us to really certify an OpenEdge release, and well, my feeling is that for the upcoming OpenEdge 12 release, we will also be very, very fast with providing support, because of course we've started testing all the various bits and pieces on OpenEdge 12 as soon as Progress started providing pre-releases, and that looks pretty positive so far. So let's talk a bit about the backend. So on the backend, we are providing a backend that follows the conventions of the OpenEdge reference architecture. That was a set of white papers and sample codes that Progress provided, I don't know, 12, 13, 14 years ago. There were some updates to the OERA. Later it was It led to the Common Component Specification project, which did not just provide white papers on how you should build components, it did lead to technical specifications for central application components like the business entity. We comply with all of them. In fact, on the business entities specification, I've been the author of the Common Component Specification for business entities that actually helped us dramatically to stay compliant or be compliant with that specification. And over the past 10 years that we're working on the Smart Component Library, sticking with the principles of the OpenEdge reference architecture, now with the component specification, really helped us to be able to integrate with new Progress products very, very quickly. I remember that when OpenEdge 11.2 was released, and with that, the first OpenEdge mobile product from Progress at that time, it literally took like a lazy Friday afternoon to prototype in a couple of hours the first integration between OpenEdge Mobile and any of our business entities. And of course, to make that then a real component of the product, it took a little bit longer. But if we wouldn't have been following similar mindsets in designing the backend than what Progress typically has, that certainly would have taken a much longer time and might not have been such a smooth experience both for us and our customers. So on the back end, yeah, there are business entities and data access objects as the key components. Business entities are business logic objects with the purpose to manage a set of tables in the database. Something like an order header and order lines could be a business entity, and the business entity should contain as the one central place of an application all validation rules and all calculated fields dealing with those of tables, and it should be easy to reuse that business entity for different clients, and also if other pieces of backend code need to talk or need to access those tables, they should also be able to leverage the business entities, so that by implementing all those validations and calculations in the business entity, we're helping to reduce redundancy of functionality, and generally that will also improve testability of the application. We also have business tasks. Business tasks are for bigger operations, could be something like a grouped transaction for multiple business entities or a report or whatever. And we provide all the common infrastructure components that are needed to really execute this application for state management, for authorization, authentication, and so on and so on. So the business logic design process, that's mainly for business entities, but also for business tasks. It's based on templates. We have a visual designer using diagrams. This visual designer is actually also an OpenEdge application that we've developed. This OpenEdge application has a plugin infrastructure that allows our customers to extend the functionality of the tool very easily with functionality like specific validation, maybe for your own naming standards, or with functionality that actually implements your naming standard whenever you add objects to a screen or to the design. Generation of additional code, maybe you have your very specific requirements for generating code, all that can pretty easily be implemented using plugins to the business end designer. And because it's an ABL application, I expect that every ABL developer will be able to understand how that can be done. So let me briefly show you this tool and build a simple business entity, starting this tool from our tools desktop. The tools desktop is like the central hub to various utilities that we provide, and allows us also to easily extend the list of tools. And in the simplest form, we just start with an empty design canvas, and I could be adding tables from the database to the design, and then drag relations between those tables. So the order has a customer, the order has multiple order lines, and the order line has an item record. So the business entity design is pretty much like producing an ER diagram for a subset of tables, for a subset of related tables. With the customer table, I could say, well, the customer table is part of this business entity, but we're actually not intending to maintain customers or items from the order table, so we can make these tables easily read-only, and then I can add validations. So maybe something as simple that an order date is a mandatory field. For the mandatory rule, I don't need additional arguments. There's some rules that require additional arguments. This rule doesn't. All this rule requires is the error message. If I don't enter anything, then we provide a default error message. Other than that, we can either type whatever we need here as a hard-coded error message, or the two fields below are referencing to a translatable error message dictionary, which we have as part of the framework functionality. And in a similar way, we can add calculated fields. So if, for instance, for the customer, we want to have a standard field with a standard calculation, then we could be saying this field should be the remaining credit limit, probably a decimal field, and we provide an expression for that and for the remaining credit. So that would be the customer dot credit limit minus the customer dot balance, and I save that expression. And so when I generate the code, the consumers of that business entity will just see that field. It will always have a value, and actually it's not distinguishable for the consumers whether or not that field is persisted in the database or calculated on the fly. So in order to use this business entity, I barely only have to provide a package name. The package is like the relative folder where the code should be generated to. I save this. And now I can generate the code. I'm prompted whether I want to save the design file in a location on my hard drive, and I say yes. This design file is allowing me to reopen the business entity later. The structure of that file is as simple as the XML representation of a pro data set with a handful of tables, and the fact that our design information is stored in something as easy as a pro data set, that makes mass changes to business entities really trivial. So if, for instance, in a year from now, the team has built many business entities, let's say 100, you have new requirements that all of those business entities should have a specific field to show a timestamp or a version of record or whatever. We don't have to open all those 100 business entities manually. It's actually a task where which you could solve in maybe 15, 30 minutes. You just have to read all those XML files into the pro data set, create a few temp table records that represent the fields, and invoke the class which implements the designer, the code generator. And so really in not much time, you are able to make massive changes to a large number of business entities. So from this tool, we can also invoke an ad hoc test utility, which allows me to test if the business entity does what it's supposed to do. And it also shows the various options that we have on the business entity. A business entity with more than one table might very easily lead to the fact that you're reading a lot of data from a database, and that might not be needed in all cases. So if you are thinking of a lookup browser to select a single order, you don't need the order lines for doing that. So our business entities are able to turn on and off the data retrieval for every of the tables. That is something that you can see here as well. And as soon as I have the customer there, then I can also see whether my calculated field is returning the right values. See, I have some customers with negative remaining credit, so that's probably already an issue. I can also look at just retrieving child tables. So I don't need business entities for every possible combination of these 4 tables. Typically, this one can serve many of the actual use cases. The other thing that this tool also provides, and it's very easy to show this when we're just looking at the customer table, we also make it very easy for a developer to guess the performance of certain queries. So if, for instance, I run a query where the city is Boston, I'm just using Boston because I know there are a couple of customers in the database, and I execute this, then I could say, oh, that doesn't look too bad. I get the result in 0.4 of a second, or 399 milliseconds. My database has 201,000 customers here. And actually, if I look at the statistics of the database, I did actually read all of them. So I know I've done a full table scan, and I know that the database administrator of my customer would probably be pretty mad at me if this happens in a production environment too often. So that's an easy indication if that's a typical query that you need, that you're either missing a field along the way to match an index, or you need to create another index, because if we're adding the USA to that query, maybe an and would be helpful, then we see we're just reading 15,000 customers now. So apparently I do have an index for country, but not one on the combination of country and city. And this gets pretty easy, pretty obvious. And why is this important? It's especially important for web development projects, where it's just more likely that you have programmers dealing with the application backend, because those are AVL Open Edge developers, and others might be dealing with new web technology. And so this makes it even more important that the Open Edge developer providing the backend has tools, and we have more of these analytic tools in place. We can also look at the efficiency of using temp tables and whatsoever, before he passes such a business entity as an application component to a front-end developer. And now that I've mentioned the front-end developer, let's leave the topic of the backend and move forward to the front-end topic. Final say on the backend. We've seen the business entity designer, which is like an ER designer, an ER diagram tool for a subset of tables, which belong together and should be forming a business logic object. For the design of the whole database, we have integrated a standard ERD diagramming tool for the Open Edge database called Zamoxis, and that allows us to look at the bigger picture, do the database diagram, and this also support some functionality that we have in the framework. We have functionality in the framework that performs referential integrity on every data update and data deletion. So on deletion, we can do delete, restrict, delete, cascade, nullify, set default, these standard rules. When we insert a record, this supports automatic validation of foreign key values, which greatly reduces the number of validations that developers actually have to code. And when you start defining reference integrity, then yeah, it's really a job that requires a graphical diagramming tool, and therefore we've integrated Salmoxis into the framework and can use this to maintain the relation information that we need for our referential integrity. We have a lot of functionality in unit testing in the framework, and helping functionality for unit testing, including functionality that allows to abstract database read. Anybody who has experience with unit testing in the context of database application knows that a database is a pretty ugly thing to manage in the context of unit tests. Maybe you have one test that tries to validate an update to a certain customer, and you expect that a certain update is successful. However, if in your long test sequence before, somebody else, one of your colleagues, tries to implement a test for successful deletion of exactly that same record, then you know that the second test will have to fail then, because the record's no longer there. Unit testing against the database is something that has a lot of problems, and we have some solutions for that. So, but let's actually start with web development. In the SmartComponent Library, we support RESTful interfaces for all of our business entities. Developing these RESTful endpoints is something where we have a standard functionality in the product. So that means that you don't need custom code. And it also means that business entities that have been developed 10 years ago, long before the RESTful standard has been formulated, also magically are now able to be accessed through a RESTful interface through our standard way here. RESTful is something that we added to the product 2 or 3 years ago, after we have received inquiries on that topic from a couple of customers. And looking forward into the future, it is probably very likely that we will be implementing other HTTP-based interfaces to business entities, maybe on standards like OData or GraphQL or whatever the future brings. These standards come and go pretty fastly these days. But generally, we should be able to implement them as a standard component without requiring a lot of custom code on the application. Why is RESTful so interesting here? RESTful is the standard way that probably every web developer understands and expects for accessing data. If you get yourself a book on modern web development, on single-page applications, they all will tell you how to deal with these RESTful endpoints. And it's also very often the foundation for providing APIs to other applications or smart devices like a Google Home or Amazon Echo. Building interaction on one of these audible devices or speaking devices is actually quite easy using the RESTful endpoints. We've also integrated a tool to document these endpoints. So maybe in a situation where the web developers that you're tasking with building a web application for you are not members of your own organization, maybe they are from a software company that you hire for that purpose, then being able to provide documentation for the endpoints that you provide them to access your data and business logic is very, very helpful for communication with those. So let me show you that. So I'm gonna navigate to the Swagger endpoint first. So I need to authenticate. Typically, the backend is requiring a login. And it's now loading a Swagger definition that the app server dynamically provides. And it shows a number of endpoints that we provide for different tables from the database. And using Swagger, it's very easy to try them out. There's actually a tryout button here. The /customers endpoint to fetch customer data allows us to filter, maybe filter on country, USA, and if I execute that, the tool will show me first the actual request that has been issued and the response here. I can also filter on combinations. So now that I've seen that there's actually in my screwed up database, a Vienna in the United States, I can run that combination and what did I use? The wrong value. So it was probably even more screwed up. We see I'm returning here a set of standard fields from that entity, country, name, and city. RESTful is a protocol where the consumer is allowed to also provide a lot of additional request arguments like the fields. So maybe I want to see custom, name, city, country, and the credit limit. Then I can provide that here. And now I see those fields that I wanted to see there. That's quite useful because the number of fields that you return has an impact on the bandwidth and so on and so on. Especially for reading data, these RESTful endpoints are actually so trivial to use that for basic testing of read operations, you don't need a tool like that. You can just navigate directly to that URL, and you see the same response there. I have the same options here, so I can say country equals USA and fields equals custom, name, city, country, and credit limit. And I'm seeing now only customers from the USA with those fields provided. And here in the browser, we see that together with the data, there are addresses for related information provided. First of all, this here is called a URL for a collection, so for a list of records. From the list of records, I can pick a single record, and it brings me to that record. And the other are links following a standard related to RESTful development, HATEOS, links to related data. So again, the backend developers that define this make it trivial for front-end developer to know how to retrieve related data like the list of orders or the list of order lines for that customer and so on. And in the list of order lines, you can still filter. So let's say I just want to have the order lines from that order with item num equals 50. And now I see I'm only getting that one. So it's a very flexible way of interacting with the data using HTTP requests. And all that requires in the business entity is an annotation where we define the standard fields that we want to show and the address. So the fact that the customer's business entity is exposed under the customer's URL and that we see those three fields, that's all result of this annotation and the rest is happening automatically. So based on these RESTful endpoints, Radu has built a very simple prototype. And for talking us through this prototype, I'm now passing it over to Radu.
Hello, everyone. So first of all, based on the customer's endpoint that Mike just showed you, I've implemented a very simple web app. It features a Kendo grid, so it's all using the Telerik Kendo UI components. It features a Kendo grid that shows a list of customers, and on the right side, a few editable fields to edit the selected customer, submit button for updating. This is done through a so-called customer service. In Angular, services are injectable, so you can request them in your components or other services. So for example, here in my services constructor, I am requesting Angular's HTTP client service. Based on the argument type, Angular will know an instance of which service to pass on initialization. So this service has a few basic methods. So it has a fetch method, which also takes in a filters argument, which is optional. If it does get a filters argument, it constructs the query string that Mike demonstrated a few minutes ago, and then simply performs a GET request. You'll notice that we're using something called a behavior subject. This is an extension of the observable class. It's something that Angular uses specifically because as opposed to promises or callbacks or things like that, it allows a view to subscribe to it and constantly receive new values as they are emitted by the subject. So basically, in our app component, we get an instance of the customer service, and we just save a reference to its customer's behavior subject here, and then in our view, you'll notice that the Kendo grid's data setting is set to our customers. So that's it. You just basically set it to customers, pass it through the async pipe to let Angular know that this is going to be async. It's not just going to be a single array of records. And whenever we get a new value for that array, the Kendo grid will update itself. So let's move on to show you this demo. So as you can see, we've loaded an initial list of records. Once we select a record, these fields get updated. Of course, these fields are updatable. We can, for example, let's say the city is London, and you'll notice it's changed in the grid as well. But let's submit, and resource updated successfully. That message is actually coming from the backend. It is not hard-coded. If we refresh it, we'll see that the city has been saved to London. We can also handle errors this way. For example, a backend validation error would be that you cannot save a customer without specifying a name for it. And there was an error while saving your changes. So the change was rejected, and if we refresh the page, we'll see that the change hasn't been saved. To filter, all we do is type in a value here, hit the Enter key, and you'll see this the list has been filtered by constructing the query string, much like Mike demonstrated here. And yeah, that's about it for this particular demo. Mike, back to you.
Well, Radu, one nasty question. So you didn't use any of our Angular front-end components to build this.
No.
Basically, the only tools you had were your decades-long TypeScript experience for writing the code together and the Kendo UI documentation. So how long did it take you to build this from scratch?
A little under an hour, not even that.
That was a little under an hour. So, and I think, not to disqualify Radu there, but every web developer that has some experience should be able to build that on top of the RESTful endpoints in a similar time. I mean, there's still a lot to do for real application. I mean, we would need to show real error messages and maybe need components like lookups and so on. But the Kendo UI components or other set of modern web components make it quite easy to build, yeah, at least simple applications like that.
Yes, also, sorry, Mike, just to interrupt, you also do bear in mind that this demo also handles authentication. It's just that the username and password are hard-coded. So something to keep in mind when thinking about the development time. Okay, so that's it, Mike.
Thanks, Radu. Okay, so that was this demo. So now we come to the JSDO-based endpoints. The JSDO is a JavaScript library provided by Progress, or nowadays it's actually a TypeScript library, TypeScript being a more modern object-oriented language that can replace JavaScript. So Progress has built this library. It's actually there since quite a few years. I think we're now in the 6th version of the JSDO, or the 6th major version of the JSDO. What the JSDO does, it basically provides a mirror image of a Pro data set for the web browser. And it knows how to communicate with business entities. It knows how to handle errors or how the business entities throw these errors. So if you're building a web or mobile application and you know your main backend is going to be that OpenEdge application, then the JSDO is a great choice and provides a lot of additional value. So with the SmartComponent Library, we provide a similar generic endpoint that exposes business entities to the JSDO. We call it generic REST service interface for JSDO-based clients. Maybe we'll need a shorter name for that. And that immediately exposes all the CRUD functionality, so creation of records, reading records, updating and deleting records of the business entity. And if there are additional methods that you want to expose to the front end in the business entity, they will also be invocable through the JSDO. The JSDO-based service interface exposes any business entity that we have, and whether or not it's accessible by a certain user is a matter of authorization. And our way of exposing business entities also supports localization. So if there are translated field labels that might be picked up by a front-end application dynamically, then we certainly provide them in the user's language if we have a translation. Progress is also having in-the-box functionality for exposing business entities to the JSDO. We're using a dynamic approach of exposing business entities. And yeah, we believe that our approach makes it much more easy to handle this, especially in a team when multiple people are working on the project and work on business entities in parallel. I think then Progress's approach has its problems. We support that with PathOE and still with the classic app server. Saying still with the classic app server because Progress has announced that the classic app server will no longer be around in OpenEdge 12. So then we will also have to stop doing that in the in the future. We have some capabilities in the JSDO through our specific approach here. We can support building screens based on any tables and fields that we have in the business entity. We're following there the MVVM approach. MVVM is one of these screen design architectures like MVC or MVP. MVVM says there's a model and a view model, and basically all it says that the way that the client navigates through data might be a different one than the way that the server navigates through data, and we can provide subsets of the data to the client to make it a more efficient solution. Using this generic approach, I once did a demo building a mobile application using Telerik Mobile. In 3 minutes and 29 seconds, I achieved to build a new business entity and a new front end to that business entity. A recording of that is available on YouTube. So if you want to spend 3 minutes and 29 seconds on that, have fun. Through the JSDO-based API or endpoints, we are also fully compatible with Kendo UI Builder. Kendo UI Builder is Progress tooling to provide development support for Kendo UI mobile applications with OpenEdge as a backend. We have customers using Kendo UI Builder for the front-end design, and through the JSDO, they're using our business entities, and that's something which we also fully support. So, but the other thing that we provide is our own Angular client, the SmartComponents NG client, NG being the short name for Angular, which is based on Kendo UI as well, and Angular. And well, why Kendo UI? Kendo UI is a very comprehensive set of UI components for the browser. A lot of those components that you know from desktop applications are provided by Kendo UI as well. Well, there are other web component libraries that claim the same thing. But in this case, I think the fact that Kendo UI is actually a product supported by Progress Software and used by many people in the Progress community makes it a great choice for teams which are having an OpenEdge backend anyway. Kendo UI works very well with the JSDO and through the JSDO with OpenEdge backends. The Kendo UI for Angular, the Angular front-end library, I think is 7 years old now or so. And when the Angular framework was made available, the actual Kendo UI library was rewritten to have really first-class support for the Angular framework. And well, here's the list of components, and so we're using some of them in our standard components, certainly not all of them, but it is possible to use them in your own code. So, and Angular, well, why Angular? Angular is again, a framework that leverages MVVM pattern for browser-based applications. Angular is supporting component-based development, so we can have different components like grids, viewers, lookups, etc., and provide a means of configuring them and having code there. It's object-oriented, makes it easy to customize those components, and so on and so on. It's just a very modern way of building web applications, single-page web applications, or mobile applications. The main drivers behind the Angular framework are Google and Microsoft. And I guess it's pretty, there's no doubt that Google has a lot of know-how in building web applications. And Microsoft is, among Progress, probably one of the very, very few companies that has experience in providing development environments, development technologies for way over 30 or 35 years. So a similar history there as Progress Software. When we had to pick a foundation web framework, we looked at what frameworks were available, and it got pretty clear that Angular is the one that we would trust most in means of future-proofness for business applications. If I would have to pick between the frameworks that Microsoft is building and maybe a framework that companies like Facebook and Twitter are building for a business application, I would certainly pick the one provided by Microsoft, because which interest should Twitter have in providing me a stable development environment for web applications that I still want to develop in 5 years from now or so. And Angular allows us to build functional components. So what we see here on the screen is an HTML layout, which combines some basic HTML layout options. Like in the top, you see this H1 sales rep, that's just a header on the page. And then we see 4 of our smart components, which Angular allows us to reference through custom HTML tags. One is the smart data source, which wraps the JSDO, which allows us to read data and update data from the backend, and have all the configuration options that we need there. We see a grid, which visualizes and allows navigation through the data of the data source. We have in the bottom a viewer, and all these components know each other through their identifiers or names. That allows us also to have multiple of these data sources and viewers on a single screen. Behind these custom HTML tags, there's basically functionality that we have developed to make that a running application. And so now I'd like to show you a bit here. So I'm navigating to the web application. Typically, business applications require a login. We can do without a login, but our standard setup is always requiring the user to authenticate himself using one of the different authentication methods that the PASOE supports. We see the application. That's one way how the application could look like. Radu's going to talk in the end a bit about customization options, but I could actually show the same application using a different URL in what we call our business theme. You see the login dialog already looks a bit different. When the page loads, we're not seeing our fox as the animal. We're having a different start view here. No, the start view is actually here. I jumped into the URL. You see the menu has a different orientation. It's now on the top. In the other view, we used this accordion-like view for rendering the menu. Basically, the content area of the application is always the same. I can navigate into a screen here and navigate into the same screen on this one as well. Then we see that here, I'm just looking at this one screen. And on the other screen, we've implemented a sort of multi-document interface through a tab folder, allowing the user to be in multiple screens at once. So all that is something that through configuration you can influence. The whole main page layout is something that a web developer or web designer could be influencing either through cascading style sheets or elements in the main page. Let me navigate through the application here. The grid implements either an infinitive scrolling, so it reads data in small chunks, and while I use the mouse wheel, it's reading more data. Well, I can use the grid columns and click them for sorting purposes. I can also filter. And when I click then on the record, I see the details on the right-hand side in the viewer. Typically, we have some form of a toolbar component on the screen to control the update process. adding new records, copying them, deleting them. I can make any changes here. You see, as soon as I start changing something here, the grid and the filter become disabled. The application now expects me to either save or cancel my update. When I make an invalid update and save it, we're seeing an error message. This error message now here is localized. I'm recognized as a German user, so it tells me the name is a mandatory field in German. And I click OK, and now I can fix that, and or I could cancel it. And when I'm done, I'm saving it, and now the changes have been persisted in the database. Since it's a web application, it's also useful to be able to apply some typical web application or user experience patterns, like breadcrumb navigation. So I went from the customer maintenance, now I'm the orders of that first customer. I can pick an order line here, navigate into the order lines, and I can use the breadcrumb here to navigate back and forth, and I could also get straight into the customer there, and the context of those pages is always persisted. It's also a quite nice way of moving through related data. I have a lookup component that we provide as a standard component, where I could pick a different sales rep here. And last but not least, and that's very important these days, where web applications may also be used by small devices like mobile phones, the whole screen is responsive. So when the screen size shrinks, like maybe the aspect ratio that you would have on a mobile phone, then the layout of the screen wraps. The menu might turn into this hamburger, which needs less space, and yeah, all the different components are still usable in a different way, and so the application adopts to that automatically. So let's move on. So the components on the screen that we've seen, well, we've had the smart data source on the simple HTML sample before, that's dealing with data. We've seen the grid component. The grid is based on the Kendo UI grid and supports, yeah, navigating through a set of data. It supports paging and infinitive scrolling. The grid can be editable or read-only. Typically, when there's a viewer on the same screen, then the grid would be read-only. We have the smart viewer, which renders a set of fields of a single record or a group of related records, supports viewing and updating them. We have the toolbar there. And we also have lookup and combo box components, which allow in a viewer to pick a value from a related table. Like when we're looking at the customer, we could be picking either the sales rep or maybe the country or the state table using either the lookup or the combo box component. And these are really the main building blocks that developers would be using to build business applications. And then these are put together using one of four ways. We have seen the HTML approach on a slide before. That HTML is basically like the standard way of designing screens in the Angular framework. It is specific to browser-based applications, and so there may be a demand for a more open design standard, and we support that through a JSON-based layout. The JSON-based layout describes the components on the screen and how they relate to each other and how the properties are, and our front-end library is able to render the screens based on this JSON layout. The nice thing there is we are able to reuse that JSON layout in native script applications, which are native mobile applications provided to mobile phones, deployed to mobile phones. And since you can build native script applications also using the Angular framework, that allows to reuse a good amount of the screen design and a good amount of the front-end code that most applications require both in the browser and in a native mobile application. That's a very powerful thing. We can, for simple screens, we can also just describe the fields which should be used in a grid and in a viewer through annotations in the business entity. And last but not least, we have a user interface repository. That's basically a set of database tables in our framework database, which can describe a UI, which can describe which columns should be there in the grid, which fields should be in the viewer, their position, and how they all should be composed together in a form. We have for the user interface repository, we have some graphical designers that support you in doing a viewer design in a more or less what you see is what you get. If we take the responsiveness that the screen needs to adopt to the actual size at runtime out of the equation, or for grids, and gives you a preview of a form. And the user interface repository layout allows to run the same screen definitions on desktop using GUI4.net, on web using Angular and Kendo UI, and on mobile using NativeScript. So let me show you a little bit of that tooling. So first, if we look at a screen here, that's a simple customer maintenance screen based on annotations. It is basically rendered from a template. There are some columns that are shown in the grid when there is enough space for it. And we have some fields in the viewer, and the rest is always the same. So if you have many screens that provide you this single table update functionality, then this might be enough. And how is that defined? Well, I've looked at the annotations of the customer business entity earlier for the RESTful endpoints. Here we have another view there, which defines in the customer business entity a view named customer. It basically defines the fields of the grid, that are these list columns, and the fields of the viewer. And the rest of the design is following responsive guidelines anyway. So it might not be required at all to do a visual design when all you would do in a visual design is actually putting fields together in the right sequence. If we look at the viewer, however, we see there are some things which are custom. First, we see the customer number field is read-only, so that's also a definition in the business entity. So that's not something we need to bother with during the screen design. The state field is read-only, which is following my personal authorization. So it looks like I, as a user, I'm not allowed to update the state here. Or no, it's actually something different. The state field here is disabled because it's not the customer from the USA, it's a customer from Belgium, and customers in Belgium don't require a state in the address. But then here we see we have the sales rep being represented by a lookup, and the comments being represented by a text editor. That's something which we do not specify in the annotations because I believe it would be too much for the annotations. However, we can influence that in the repository. So I'm starting the repository tooling now. And currently, our repository tooling is implemented in a Windows desktop application. We are planning to provide the tools to maintain the repository database as a browser-based application as well. It's not having the highest priority for us because OpenEdge developers require desktops anyway for Progress Developer Studio. But it is something that we are working on. And as part of the repository maintenance tools, we can, for instance, map fields from business entities using naming patterns with objects known to the repository. And here we see, for instance, two fields that we've had in the screen there too. We see that for the e-customer sales web field, we want to reference an object called the sales web lookup, which is known to the repository. And for the comments field in any table, so we're using a can do like matching there, we're referencing an editor component with certain properties. So now we can look into the maintenance of these objects, and these objects, when they're maintained by themselves, there's no graphical representation. You can't have a lookup like that, but we have here a property sheet, and that property sheet defines all the required properties for that lookup. And the other one was the editor component, and that, for instance, defines the height of the editor, and we could also be defining HTML style attributes and whatsoever. So these are now objects where the properties are defined in the repository, are centrally reusable as components, and still referenced in the web design. If we now look at the customer form that we were working with in the beginning, that form is actually not rendered just based on annotations. It's rendered based on the repository. And we see there are certain properties of that form, like the title of that form. We don't have tab pages in this one. We could have tab pages there. We have instances of other objects. We have here the reference to the filter components, the grid components, the viewer, etc. These components, I could open them in the designer here, and then we see specific visual designers for these objects. So I'm seeing a preview here of this customer grid. And if I would make changes to the way the columns are arranged here, that would then be come visible in the browser. The same for the viewer. The viewer is an object by itself too. And that is composed of a set of instances, and I can also open that in the designer. The first time I open the viewer designer takes some time because it's actually loading components of the .NET design time framework into this environment here. The layout that we have here, it is providing the foundation for this layout. We see the group boxes here are represented, and if I would change the orientation of the fields here, let's get all these nice supporting guidelines there, and I would save that, then that would become visible on the screen immediately. The group boxes support also the responsive design. So if the screen gets too small, then we see that the viewer wraps the customer and the contact information so that they are appearing under each other and not next to each other. So the design, well, it cannot always be what you see is what you get because of the responsiveness, but I believe that this viewer is actually quite helpful to design the screens and change properties of the individual components. And here we also see the same lookup control being referenced that was also referenced in the other screen just by mapping the repository field. So let's move on. Custom component development. Now Radu is going to show some options how we can extend the repository-based screens with custom code or with your own components. Radu?
Hi again, everyone. Mike, it seems that sorry about that. Had a little lag, bad internet connection. First, let's talk a bit about styling. So the SmartComponent Library framework for Angular uses all the standard Bootstrap conventions. Bootstrap is it's a framework that provides many built-in CSS classes that you can easily use in your code to provide things like responsiveness, just basic layout configuration, hiding or unhiding screen elements based on screen size, and you can do that simply by applying a CSS class, and that's it. No extra code necessary. We follow all the Bootstrap conventions, so if you're already familiar with Bootstrap as a web developer, maybe, then this would be quite handy for you. Also, since we are using the Kendo UI components, we are also compatible with the Kendo UI theme builder. The Kendo UI theme builder is it's an online tool in which you can configure every visual aspect of every component that is available. So you can configure the styling for using a nice GUI interface for inputs, grids, charts, or MDI interfaces or anything. And then you simply download the CSS file, plug it into your project, and your whole app's theme will instantly be changed.
Are you saying, Radu, that somebody who knows as little about JavaScript and cascading style sheets as I and actually doesn't want to learn anything about that could change the style with that tool?
Oh yes, the style of the whole web application using a nice online GUI interface. Which shows you live previews of your changes. You have nice color pickers for everything, and you just get a CSS file, then write exactly one line of code to plug it into your project, and that's it. That's it. Also, it's easy to implement any custom styling that might not be there in the Kendo UI theme builder. That's such styling that is specific to our components, because we also have many built-in CSS classes, so you can just use those. For example, you could add a CSS rule that smart filter fields in a vertically oriented smart filter might need to have gray borders, for example. That would be very easy to implement using using our built-in CSS classes. Custom layout support for static components. So we also have just one second. So when what Mike showed you earlier, the demo, you saw that you could have either an MDI interface or a non-MDI interface. You had in the non-MDI interface, you had our Fox logo in the bottom of the page, some copyright information, and all of that. That is actually a root component. So you can think of it as a container for the forms that get rendered on the screen. We actually have a CLI-based generator that will generate this root component for you. It will add elements that are configurable by means of the CLI tools, such as copyright information, maybe a logo, and all of that. And then it also adjusts your Angular Zap module to bootstrap that instead of the standard app component. and basically then you have a nice pre-built HTML template with all those elements that is very easy to then customize. So now moving on to client-side logic. So forms don't necessarily need to have any form of code in you don't necessarily need to have any code in your Angular project to render smart forms, because they can be the layouts can be repository based, and if you don't require any custom logic, such as disabling the state field if the customer is not from the US, then that's fine. But if you do need custom logic, we also have a nice CLI tool for that. It will just ask you what the layout URL is, or if you want it to be HTML based or JSON layout based, and it will generate for you a component that extends the smart form component, and then you can add custom code for that. I'll be showing you some code related to this in a few minutes. Event handlers and component APIs. So in JSON layouts, for example, you might be wondering, well, okay, if I have a smart viewer layout and I have a button there, how do I define what happens when the user clicks that button? You just define a handler for that. So, but the handler is basically in the JSON layout just the name of a method in your custom form, and then you just implement your logic in that method in your custom form. Custom components are any Angular component that you might implement. You just implement your component the way you would any Angular component. For example, maybe a custom calendar component or something that you would like to be part of a form, and you just add the smart custom component annotation to it, give it an ID, and then you can reference that in your JSON layout, and it will get rendered at the specific spot in the at runtime. Yeah, like I was saying, forms are easy to generate using the CLI tool. You have your choice of HTML or JSON. The form layout, this is nice, may reside in the backend repository or as part of the Angular frontend app. So you could have a JSON layout that you not necessarily want to generate it from annotations, but you can have a simple JSON file in your Angular application, and the smart form does know how to use that and render it. Static types. So with the CLI tool, you can generate TypeScript definition files so that you can have strong type support, strong typed access to temp table fields. This provides code suggestions, code completion, and all of that. It's a very handy tool. Right, the custom components, as mentioned earlier, they have access to all the SmartComponent Library APIs, so you can get instances to our services, to our widget factories, and all of that inside a custom component. They can be used in both custom layouts and annotations-based layouts through the backend tooling. And they can be rendered at any place within a smart form using placeholders. Okay, now time for a demo. Just 1 second.
Radu, that would be in the demo folder.
Yes, keyboard doesn't seem to be working anymore. Ah, there we go.
I need to hijack the mouse because I need to unmute me. Sorry.
Okay. Mike, if you could please move the Visual Studio Code window. Ah,
That's just one.
yes. Keyboard off again.
So we're going to a different demo application. The first one we had was the simple one, which had no connection to our framework. And now this is the front-end development project for our framework-based demo application.
Yes, indeed. This is the what I'm about to show now is actually the business theme demo that Mike showed earlier. So first, let's start this up.
So like for the backend development, we are leveraging the standard Progress Developer Studio functionality for editing that. For the front-end development, we're also relying on standard web development tooling like Microsoft Visual Studio Code or any other current text editor with support for web tooling will do as well. But Visual Studio Code seems to be like the standard choice for most web developers these days.
That is true.
Maybe you can guess that Microsoft was involved in Angular by the accuracy of the percentage estimate.
Okay, so for the purposes of this demo, I've implemented a pretty simple custom smart form. So this is actually rendered based on a JSON layout, which is being served by the backend. As you can see, we have here what Mike showed you earlier. We have an order screen and we have the smart viewer on the right. But what we also have is a calendar component above the viewer. This is actually a custom component. It is not part of the Smart Components package. It's just the Kendo UI calendar, which we are rendering dynamically based on the JSON layout. So with this calendar component, we highlight here. So these dates that are colored red mean that there are actually orders in these dates, and they are loaded in the front end. If we were to select a date from here, the grid actually selects that date. And if we select a month, we filter based on that month. So now we're only getting orders from January 2009. Okay. This is done by generating a custom form. So we have here our forms folder, and here we have a custom orders form. This is generated as easy as typing SCL generate form in your favorite command line, emulator. As you can see, we have here the custom smart form annotation, and in here is the form ID. This is used by the backend to pair forms with Angular roots. So the web app will know which form to render at which URL. Okay. These are two of our of the services that the Smart Component Library framework provides: the data source registry and the Smart Viewer registry service. So if you're using a JSON layout, you might need a way to programmatically gain access to instances of data sources or smart viewers or any component. We have such registries for most of our components. This method here, this is part of the generated code. It basically just sets the layout to this URL here. So it fetches it from the backend. And yeah, this here is custom logic added specifically for this form. Here we get a reference to the orders data source from the data source registry and save it. Here we get a reference to the order smart viewer because we need to react to the view shipping address button. So when we subscribe to the viewer button clicked event, and then we react to it by calling the view shipping address method that we implemented, which is which mainly just constructs a query string and then opens that address as a query in the Google Maps website. Embedding the map would be just as easy, but for the purposes of a web app, if you do it this way with a URL, then on a mobile device, it will actually attempt to open the Google Maps app instead of opening it in a browser. Okay.
Radu, do you want to show that in the application? Because I think I didn't show that part.
Okay, sure. So we have the view shipping address button. We click on it, and it just opened the Google Maps page at the customer's address right here. That's what that button does. Okay. Now for the custom calendar component. So we can see we have here a few files. We have the TypeScript file. We have the HTML file, which is basically where we defined our layout. This is standard for any Angular component, really. As you can see, there are two Kendo calendars defined here, and we have event handlers for each of them's value changed events.
Could you please add a label above the calendars saying, please select the month and please select the day?
Above each calendar?
Just by adding some text around them to show that this is really combining standard HTML elements with references to Kendo UI components.
Okay. So now it's recompiling because it detected a change. And once it's done, the web app should be refreshed. Yep, it's refreshing automatically. So as you can see, now we have in our custom component a please select the month and date message. Okay, so going back, this custom calendar component gets a reference to our data source registry. It also gets its own reference of the order data source. And for example, if we when we change the value, when we change the selection in one of the calendars, we either filter the data source, or we perform a fetch on the data source, like so, for example. And then this, because all the views are linked to the same data source, this gets reflected in all the components. So the calendars, the smart grid, and the smart viewer, which are all they're rendered there based on the JSON layouts. I can actually show you the JSON layout so you can see where this custom smart form is actually defined. Just 1 second. Okay, so as you can see in this JSON layout, we have a data sources node. This is where our orders data source is defined. Then our form layout is split in columns. This is actually configurable. You can have either a columns-based layout or a rows-based layout, depending on what your needs are. The split container, so this component, the split container, is also defined in the JSON layout, and you have left and right properties for it. And as you can see on the left side of the split container, you get a orders calendar, which is just told that it's okay, it's a custom component, and you give it the placeholder ID. And in this case, also some styling that gets applied at runtime. This placeholder ID is actually this. No, sorry, wrong component. It is. It's actually this. Yeah. So as you can see in the JSON layout, you can really play with it, move it around. You could, like I said, you can actually implement such a JSON layout as part of the Angular project if you would like. I also want to talk a bit about what I mentioned earlier regarding themes. So this is the business theme. Mike also showed you the classic theme. Now all the different styling that gets applied in the business theme is actually here, biz theme. It is this CSS file, which I didn't actually write. I mean, look at it. Of course, I didn't actually write it. It was generated by the Kendo UI theme builder that I mentioned earlier. So all I did was navigate to their nice GUI tool, specify some colors and some styling options, and downloaded this CSS file, which I then included here. This is the one line of code, and that's it. That's all you need to do to implement a custom CSS theme that really applies to all components throughout your app. And I would say that's about it for now. Mike, if you have any other questions.
Well, thank you, Radu. Let me close this off with showing where the custom component is referenced in the backend tooling, because I guess not everybody is fond of writing the JSON files that you've shown manually. So I'm going to open the repository definition for this order calendar screen. Order calendar form, this one. And so there we see the screen where Radu showed us the JSON layout. We see how the screen is composed. It has the split container. It has other components in the split container. As part of those, we see the orders grid as a reusable component. So we can use the same grid definition in multiple screens, same with the viewer. We see our standard toolbar. And we see there the orders calendar. And the orders calendar, it's a component of the type, custom component. As the properties, we see here the reference to the placeholder ID that Radu showed us in the backend. That's actually the link to the implementation in the backend. And we can also look at a preview of the form. The preview of the form is in this case just showing how the components are organized, usually forgetting the real preview. There's no problem in running a live preview of that component, of that form, either in the web application as we've seen, or even in GUI for .NET desktop tooling. And sometimes there are good reasons to get the JSON layout of the form statically. Currently, we're requesting that always from the backend, which might have some network bandwidth implications. But there's also a button here which would export the JSON for the form to a file, which you could then include into the front-end app so that it would be hosted as a pre-built layout on the web server and not dynamically being requested from the backend. So there are pros and cons with both. Yeah, but with this, we're coming to an end of this webinar. If you have any questions, I'm gonna stay here for a couple more minutes. Please use the chat panel of GoToMeeting and ask your questions, or email us later. Those that don't have questions, thanks for your time on this Friday afternoon or Friday morning. And yeah, Radu, thanks for supporting me, and hope to talk to you soon.